Hey guys, so today we're going to talk about synthetic division of polynomials. This is one method you can use to divide polynomials in certain cases. So this is a method that cannot be used when dividing any set of polynomials, but we'll talk about specifically when it is a good method to use when dividing polynomials. This goes with the learning target for today. I can divide polynomials. So let's talk about some dividing vocabulary before we move into the actual division. So this is taking a step back into our elementary school days where we were first learning division. And we learned this dividing vocabulary. So we have a dividend, which is what we are dividing, divided by the divisor. So you have what you're dividing divided by the divisor. And that's going to equal your answer, which an answer to a division problem is called the quotient, plus your remainder divided by your divisor, right? Where the remainder is anything that's left over after being able to evenly divide into divide the divisor, after you're able to evenly divide the divisor into your dividend. So for example here, this problem, 125 divided by 4 equals 31 plus 1 over 4. The 125 is your dividend, the 4 is your divisor, the 31 is your quotient, 1 is your remainder, and then the divisor stays the same. It's just that 4. So we're just taking that 4 and we're placing it underneath the remainder because that's the piece left over that we were not able to divide evenly by 4. So when we're thinking about synthetic division of polynomials, the first kind of key thing for us here is that this is a process we can use to divide two polynomials using the coefficients and the constants, which for a lot of people just makes it a little bit more well organized and seamless than some of the other methods that are available, like long division of polynomials. The key thing, though, is that we cannot always use synthetic division. In fact, in order to use synthetic division, the divisor must be a linear binomial with a coefficient of 1. Or we need to be able to factor out a greatest common factor from everything, dividend and divisor, in order to get the divisor to be a linear binomial with a coefficient of 1. So that's going to look something like x plus or minus a number. So we can't have 2x plus or minus a number. We can't have an x squared. It has to be linear for us here. When we're setting up our synthetic division, which we'll see momentarily, we are going to set it up using the 0 or the root of the divisor. So we're not actually going to use this whole piece. We're going to use this number here, and we'll talk through how we find that root or 0 to remind us when we're doing our setup. And then finally, when we are setting up with synthetic division, we're setting up for all terms, even if one is considered missing. So for example, if you have, if your dividend starts with an x to the third power, a cubic term, you have to have a coefficient or a constant for x cubed, x squared, x, and your constant, even if one of those is missing from the actual polynomial. So we will have an example that shows that, but it's just really important. It's a big note. That's a common mistake that is made, is not noticing those missing terms. So let's talk about the steps. The steps may look overwhelming as we go over them, but you'll see that it's very repetitive once we have this set up. So your first step is to find the root or the 0 of the divisor. This is part of the setup. It's very quick, especially considering we have linear binomials with coefficients, leading coefficients of 1. So this is going to be a really quick and easy setup. You just switch the sign of the constant in the divisor, but we'll show exactly how that works. And it's important to remember that that's the root or the 0 for when you actually start applying division of polynomials. Step 2 then is to write out the coefficients of the polynomial, and this is the step where we have to be extra careful of those missing terms, which again we will see in an example. Step 3 is you're just going to bring down the first coefficient. Step 4 is going to be to multiply the first coefficient by the new divisor and write the product under the next coefficient. So for right now, just write these down and we'll see what this actually looks like for us in just a moment. Step 5 is to add the coefficient and that product from step 4 and then repeat. So this is going to be a lot of multiply, add, multiply, add, multiply, add until you've done everything, until you've multiplied and added and there's nothing else. There are no more coefficients or constants left. So we're going to go over these 2 examples with just the synthetic part, the synthetic division portion at this point, and then we'll come back and do one start to finish at the end of the video. So as I'm looking here, my first step is to find the 0 of the divisor. And when I'm finding the 0 of the divisor, I'm thinking about what x value would make just the divisor equal to 0. So in this case, since I have x plus 1, the 0 of this divisor is -1. That -1 I'm going to put in a little box over at the left side here to help me remember that that is the 0. My next step then is to pull down the coefficients and the constant from my dividend. So that means I'm going to bring the 3, the -4, the 2, and the -1. And those are just going to be written in line next to this box. So 3, -4, giving yourself a little bit of space between each of those numbers, just for the sake of having space to do your work. Next, let's give about 1 line of space here, and then we'll draw a line straight across, because we need the space in here to write numbers. And then our answer from our synthetic division will come under here, underneath that line. So now that we have the setup, our first step here is to bring down the first coefficient. So we're not actually going to do any calculation with it first. We're just going to bring it straight underneath that line. Then, using my the 0 from over here, we're going to multiply to that number underneath. And it's going to come up under the next number. So -1 times 3 give me -3. That's where I do that division. And then we're going to add straight down. So -4 plus -3 gives me -7. Then we're going to multiply by that -1 again. So -1 times -7 would give me +7. And again, add straight down to get 9. One more time, multiplying -1 times 9 to give me -9. And then adding straight down, -1 plus -9 to give me -10. So along the bottom, we'll have 3, -7, 9, -10. I know I can stop here because there aren't any more numbers after that constant of -1 from my dividend. Let's take a look at this second example. What's different about this one is that we have x to the 3rd to start, but we don't have an x squared term. So this is where we were talking about having missing terms. So we'll have to be careful with that as we go into this, this setup. Everything else, once everything is set up, stays the same. We just have to be extra careful with the setup. So if I'm going over to my divisor here, I'm thinking about what is the 0 of this? I have x plus 4, so x equals -4 would be my divisor. So I'll have my -4 in the box to the left, and then filling in with my coefficients. I've got 1 for my x to the 3rd, nothing for x squared, so I need that placeholder 0 for x squared. So it's my x to the 3rd, x squared, -13 for my x, and 12 as my constant. And then again, putting that line across the bottom. So we bring that leading coefficient straight down. You're gonna have to let me finish. Bring that leading coefficient straight down underneath. And this is where we multiply by that -4. -4 times 1 gives me -4. Yes, I'm going to put it under the 0, since that is my next coefficient, because it was a coefficient of 0. Add to get -4. That I was there multiplying again. -4 times -4 gives me +16. Add to get 3. -4 times +3 gives me -12. And then adding here at the end, 12 plus -12 would give me 0. Now that we've done a couple of examples of synthetic division, let's actually talk about how we write out our final quotient, our final answer to these division problems. So we're going to work backwards from the right side to the left side at the bottom of your synthetic division. And the reason I like to work backwards is so that I don't make any mistakes when I am writing out my terms, and I make sure that I get them all correct. The farthest to the right, that first number on the right, is always your remainder. Whether it's 0 or something else, that's always the remainder. And we will write that as that whatever that number is over our divisor. A remainder of 0 does tell us that the divisor is a factor of the dividend, right? Because the divisor divided evenly into the dividend, which means that's a factor by definition. So then once we know what our remainder is, as we're moving from right to left, we had our remainder, and then we have our constant, our x squared, x to the third, et cetera, where you'll just work your way up one exponent at a time until you have taken care of all of the numbers under your synthetic division. So let's go back to see what we've already done and use those. So this was the first example we did. We got 3, -7, 9, and -10. So working to write out this final answer, the -10 is my remainder. 9 is the constant. I'll have -7x and 3x squared. So the 3, the -7 will be coefficients. The 9 will be my constant. And then I write my remainder over my original divisor of x plus 1. So that will look like 3x squared minus 7x plus 9 minus, since it was a -10, minus 10 over x plus 1, where again that x plus 1 is coming from my original divisor. Let's look at the second example we did. So in this case, the 0 is still the remainder. It just means that there is no remainder. So I don't actually have to write this one in my final answer. Constant, -4 with my x, 1 with my x squared. So I would have x squared minus 4x plus 3, because again, the remainder was 0, so we don't have to write it. So here's our final example, and this is the one we're going to go through from start to finish, where we do all of the synthetic division and then write out our final answer. So again, starting from our divisor, x minus 2 this time, the 0 for this would be x equals +2. So that would go in my box to the left. Notice this time we're starting from an x to the 4th power, which means we should have x to the 3rd, x squared, x, and a constant. So in this case, my x to the 4th has a coefficient of 1. I don't have an x to the 3rd, so I need that 0 for x to the 3rd. My x squared then is that -9. X is 20, and my constant is -13. So technically we could use synthetic division to do any length of polynomial as my dividend, again, as long as we have a linear binomial with a coefficient of, a leading coefficient of 1 for our divisor. So here, drawing my line, same steps as before. bring down the 1, multiply. 2 times 1 gives me 2, add, give me 2. 2 times 2 gives me 4, add, -5. 2 times -5 gives me -10, add 10. 2 times 10 gives me 20, add 7. So this is where we stopped on our previous examples, and then we just learned now how to work backwards to write out our final answer here. So I always know, again, working from right to left, this is going to be my remainder, my constant, x squared, x to the third. As a check for yourself, your final answer for synthetic division problems, the degree of your final answer should always be 1 less than the degree that you started with. So my final answer here would be x cubed plus 2x squared minus 5x plus 10 plus, since that's a positive, 7 over my divisor of x minus 2.